CT scanning of vertebrate fossils has become more widespread in the last 3 or 4 years. And it has been used on huge specimens such as the skull of the Tyrannosaurus rex called Sue, which is at the Field Museum. And with great results. You can see all sorts of details of the specimen which help you prepare it from the sediment. So if you can actually CT scan it in the block, it can tell you where the bits of bone have been displaced and help you do preparation work. But also it will help to describe specimens where the sediment is too hard to take away from the specimen itself, from the actual fossil. And it has been done once or twice in the past, that a fossil has been described purely on the basis of a CT scan. We are advancing in the types of CT scanning that we have available. Industry is using them a lot more, so they are really making them a little bit more refined. And therefore with smaller fossils, we are getting to the state where we can actually do CT scans and get better results. So it's a fairly new technique in paleontology, but it's still very, very expensive. The electron beam from the CT scanner has got to differentiate, react differently to the sediment than to the bone. So we can see on the CT scan when we're actually conducting, it takes about 6 hours or so to go through one of these specimens because it just basically goes up and down through it and we take slices through it. What we see are the fossil from the side view. So we only see slight differences. We see these little light, sort of brighter areas where it's hitting the bone. But it's just in cross-section. So we have no clue if it really is differentiating to a nice extent between the bone and the sediment. We then have to put these stacks of slices, of thousands or so slices together, and then reslice at an oblique angle on a computer. So this is all through a computer program to reslice through it and then see what we have. So it's a long, long process before you really know how successful you've been.